Okay, 1.6 homework. First problem gives us a graph of this exponential function that's been shifted. When you subtract 2 from x, it moves the function. You think it would move it left because you're subtracting from x, but it moves it to the right. So we move it right 2 units. And then when you subtract 3 outside of the function, that moves the function down. So I'm going to say -3 here. Moves it down 3. And I just put this on your formula sheet, so if you pull up your formula sheet, you'll see this whole section on transforming functions, which tells you exactly what to do. And this is how it made sense to me. So you might not want to pay attention to this, or you might want to think about it your own way. But for shifts here, horizontal shift, if you subtract from x, it goes right. If you add to x, it goes left. Now for vertical shift, I said subtract from y, it goes up, and add to y, it goes down. So that's kind of the opposite. Like if you move this 3 over, let's call this y. So y equals e to the x minus 2. And if you move the 3 over, it'd be y plus 3. So I kind of like looked at it like that. Like if you're adding 3 to y right here, that'd be the same thing as subtracting 3 outside of this term. But if you add 3 to y, it moves it down. That's what I put in the formula sheet. Right here. So it's up to you how you want to look at it. If you just remember that when you subtract outside of the x term, it moves it down, and so on. That's fine. However you want to look at it. And the next problem is problem 2. We've got a parabola here. The vertex that you want to pay attention to, because normally with a parabola, the vertex goes to the origin. This one's been shifted over 3 and down 2. So y equals x squared, but instead of x, we're going to have x minus 3 because we moved it to the right 3. And then we also moved it down 2, so we're going to subtract 2, or add 2 to y, however you want to look at it. But that becomes our formula that we would then put right here. And it's not y, it's g of x, which they already have entered in, so we just need to enter in this part. All right, next problem gives us 4 circles and 4 equations. We got to match these. So the first one's just a regular circle, x squared. That's supposed to be squared. I don't know why it copied over as this double asterisk. It's x squared plus y squared equals 1. So that would be just a regular circle that hasn't been shifted at all because you haven't subtracted anything from x and y, so that's b. Next one, you subtract 1 from x, so that moves it to the right one. And you don't do anything to y, so that'd be d. The next one, you don't do anything to x, but you subtract 1 to y, so that move it up 1, so that'd be c. The next one, you subtract 1 from x, that moves it to the right, and then subtract 1 from y, so that moves it up, so that'd be a. All right, the next problem gives us a parabola, and it wants just to talk about how it's been shifted, and it gives us some red, yellow, green, and blue here. So first one, a stretch horizontally. A stretch horizontally would make it fatter, so that'd be the red one, but keep it pretty much the same height above the axis. So that'd be A. A shift right would be the blue one, which is D. A shrink vertically would make the graph fatter. So that'd be like the green one. And then a shift down would just be the yellow one, which is B. And I'm sorry, I messed up. D and B should be switched in mine. The shift. Oh, I'm sorry. This is a little bit different. The stretch horizontally would be green, so that'd be C. The shift right would be the blue one. Had that one right. The shrink vertically would be the red one, which is A. And then the shift down is the yellow one, which is B. Had a couple of those mixed up. Sorry about that. Okay, the next one then gives us this function, the quadratic, standard quadratic. And it says it shows the graphs of f, these other 2 graphs, which this one has a 2 in front of it, this one's being multiplied by 1/2. So we need to find a function for this one now, which it says it's been shifted and scaled right here. So, okay, so we know that this is y equals x squared, but we have to add 1 to x to move it to the left, 1. but we also have to subtract 1 outside here, or add 1 to y on the side, either way, to get it to move down 1. And then there's still an a term right here. I don't know what it is. It's either 1. They told me it's either 1/2 or 2, depending. Now, to figure out what that is, what I can do is just take this other pair right here, order pair 0, 1, take that other point, plug it in for x and y. So plug in 1 for y and 0 for x. We can find out what a is. So add 1 to both sides, you get 2 equals a, so a is 2. So this term better be 2 right here. And this is my quadratic that they want me to enter in right here. And they call it g of x. Okay, this is just a sine function. If we add 14, that moves it left 14 units, that'd be a. If we subtract 14 outside, that moves it down 14 units, that'd be d. If we subtract 14 from x, that moves it to the right 14 units, that'd be c. The one on the left is b. Okay, the next problem wants us to pick how this graph has been transformed from y equals e to the negative x. So I'm going to have to rearrange this a little bit so it makes more sense to me. So I'm going to do 2 plus, I'll distribute the 5 to both terms. So I get 5 plus 5e to the negative x. And I'll add like terms 7. I'll make this 5e to the negative x plus 7. Alright, so now I can see it's been shifted up 7 units. That's that. So it's got to be this one then. And it's also this 5 right here. If you divide it by y, move it over here. On the formula sheet, we talk about how that's a vertical shift because a vertical stretch, I'm sorry, right here. Because you're dividing y by a number bigger than 1. If you divided y by a number bigger than 1, it's a vertical stretch. So it's also a vertical stretch. So it's c. You can kind of see this from a graph. If you look at a graph like on decimals, it's been moved up 7 units and it's been stretched vertically as well. It's a little hard to see that from this graph because the shape's similar, but it has been definitely moved up 7 units. And the only option that says up 7 units is C anyway. So, all right, the next problem says we have this function right here, and what is the new equation if we shift it 3 units upward? Well, 3 units upward would give us this equation 8 to the x plus 3. To the left, it would be x to the x plus 2. About the x and y axis, we'd have to change the sign on both the x and the y. So we change the sign on the y, we can move it here, and change the sign on the x as well. That would reflect over the x and the y. And the last one's the trickiest one. Reflecting the line y equals, or x equals -4. All right, so the function looks like this. It's an exponential. It always goes through 0, 1. All these exponentials go through 0, 1. If I'm going to reflect it over the line 1, 2, 3, 4, line x equals -4, that's this line. So what I'm going to do is I'm going to go back 5, 6, 7, 8 to find some symmetry here. So I'll do this green function now. I'll go back 8 up 1 so that this point is 4 units away from this line of symmetry in each way, and I'll draw it like this. So go like this then. Alright, so I need to get that green function. Now to get that green function, what I'm going to do is take the red one and I'm going to reflect it over the line over the y-axis, like this. So I'd have this function. And then I'm going to shift it back 8 units. So to reflect it over the x-axis, I change the sign on x. So that'd be y equals 8 to the negative x. And then I need to shift it back 8 units. So to shift it back 8 units, I need to add 8 to x. So that'd be my equation that goes right there. The next problem gives us the square root function, which we know the parent function looks like this. And it wants us to talk about, okay, what happens if we add 5 to x? Well, that's going to move it to the left, so that'd be d. If we add 5 to x, it's going to move it to the left, and we subtract 5, it's going to move it down, so that'd be c. So there's 2 left, and we have to figure out whether it's a or b for these. Now, on the formula sheet, I say when graphing a translated parent function, remember to do scale changes and reflections first. So you can tell, like for example, on this one I'm going to reflect it first. This negative sign is going to reflect it over the x-axis. Alright, so that'd be, this square root would be reflected like down here. And then I would move it 5 units left and then 5 units up. So that'd be b. What's left over is a. Okay, the next function is just like our parent function x squared. We got to give an equation for it, but it's been moved over 1. It's been reflected too over the x-axis, so I need to make this negative. I need to move it over 1, which means I need to take x and I need to subtract 1 from it, and then it's been moved up 4, so I need to add 4 as well. The other thing we need to look at is it goes through the point 0, 1. So I'm not sure, it could have another value here for a, so it could be a vertical stretch or shrink of some sort. So let's find that. If we plug in the point, it goes through the point 0, 1, let's plug in 1 for y, and plug in 0 for x, and you get this. And then just solve. So subtract 4 from both sides, gives you negative 3 equals negative a times 1, negative 1 squared is 1, so a equals 3. So we do have to have a 3 in front of here as well, so it's going to be y equals negative 3. So there's our final answer. Okay, the next problem, we have an equation. This is the function. It's an exponential function with base 3, so y equals 3 to the x. Now they say, what if we multiply the function by 0.5? Well, if we multiply the function by 0.5, we have y equals 1/2 or 0.5 3 to the x. Okay, so we can first figure out what the y-intercept is, because the y-intercept happens when x is 0. So if you plug in 0, you get 3 to the 0 is 1, so it's 1/2. So it goes through 1/2, so it's got to be d, we already know. But we also know that this 1/2 right here is going to be multiplied by the function, or if you divide it to the other side by this y, like I have in the formula sheet, that's a number between 0 and 1, so it's a vertical shrink. So, you know, you would expect to see this thing be vertically shrunk down a little bit from its parent function, and it is. So it's d. All right, and the last problem says you have a function and you're going to multiply x by 84. What does that do to the parent function? Well, in comparison to the parent function, what is that? Well, it's a little confusing. On the formula sheet, multiplying by 84 is really dividing by 1 over 84. And I had to put it on the formula sheet a certain way, because you find that number sometimes in front of x, but sometimes you find in the denominator like 3, x over 3. I had to make a decision about how to put it, but here's what I did. If you rewrite 84 by 1 over 84, you look at the formula sheet, you're dividing by a number between 0 and 1, because 1 over 84 is between 0 and 1. So it's a horizontal shrink by a factor of 1 over 84. Okay, so I could have did it the other way around, but it's a horizontal shrink by a factor of 1 over 84. And I hope this helps.